Hello and welcome to the next set of mathematical reasoning notes. We're in section 4D. In this section we're going to talk about loans for like credit cards, mortgages, anything you got to borrow money for. Some of the basics, things we really need to know about loans when you purchase things for school, vehicles, houses, and you borrow money, that's a loan. We usually pay a portion of the cost up front, maybe more so with things like houses and sometimes vehicles. That portion is called a down payment. So a lot of times, you'll go buy a house that's $200,000. You're not going to borrow $200,000. You're going to pay 5, 10, 50,000 down before you borrow for the house. So if you pay 10,000, then you only borrow 190,000. And the down payment really depends on your situation, on the requirement of the lenders, that kind of thing. The amount you actually borrow is called the principal. So even though the house costs 200,000, the 190 that we borrow is the principal. And then there's a set amount of time you have to pay the loan back. That's called the term. So typically houses you have 15 or 30 years. School loans usually have about 10 years. Vehicles kind of vary, but somewhere like from 5 to 7 years. So suppose you borrow at $10,000 at an annual interest rate of 5%. What would happen if you only paid back the interest each month? I like to talk about this a lot in the book, and you see it in the homework and stuff. It's really a silly idea because if you only pay the interest, you never pay back the loan. So at the end of each month, you'd take 5% of that, I guess 1/12 of 5% of that 10,000, and that's the interest, and that would give you, all you'd have is the interest payment. You'd just be making an interest payment, and the $10,000 would just sit there forever, and you just have to keep paying interest payments forever. And it's actually typically not allowed to do that. We don't want people stuck in this situation where all they can do is pay the interest forever. That's why credit card companies, when you borrow on a credit card and you have money on a credit card, you have a minimum payment each month. It's not just because the credit card wants the money, but it's also because the government doesn't want credit cards to let people just sit there and pay interest all the time. So that minimum payment also includes a little bit of principal, on that. Okay, but what if you pay more than this, just the interest? Let's say you pay $200 over the interest each month. Well, then each month you would pay $200 of the principal, and so the principal would decrease by $200 after each month. Now, some questions like how long would it take your loan to pay off, and what would the monthly payment be? And these are actually not easy questions. So let's look at this chart I made down here, and this shows what happens for the first 21 months. So at the beginning, you borrowed $10,000. Your first payment to make $200 over the interest ends up being 5% ends up being $500. You have to pay $700. So that gives you the $500 interest plus $200 principal. You can see most of that first payment is interest. Well, after that month, when you've paid that $700, now the principal is down to $9,800 because you paid off $200 principal. And the next payment is smaller because now instead of having $10,000 and doing 5%, there's $9,800 doing 5%. So now this payment's only $690. And the same thing with the next payment. Now it's also lower because the principal's gone down another $200. So every month that principal is going down $200, and the interest is also decreasing. And you can notice that the interest in this situation is going down $10 each month. In real life, it's not usually this clean because you're not usually paying such precise numbers, and you don't usually borrow nice round numbers of like 10,000. But that's what's happening in this situation. In real life, that's kind of what happens too. If you have a loan and you start paying it off each month, you make payments each month to get it lower, the principal goes down every month, so eventually it goes down to zero, and that's when you pay it off. And your payment, if you pay an exact amount of principal each month, if you pay this much, like $200 principal, that would go down as well. Now, for budgeting, this would get really confusing. Also, you have to start with really big payments, and then your payments get smaller, which is nice that they get smaller, but most people don't start off having more money and then have less later. It usually works the other way around, right? You work a job longer, you end up, getting promoted, getting raises, stuff like that. So you'd rather make the smaller payments early and the bigger payments later, or at least just average them out. No one really wants to pay big payments to start with and then pay small payments, later. That's not usually what people want. So this kind of setup is not really a great idea. So we don't really do payments like this. You could, but it's just not common. So most of the time when people borrow, they do what's called an installment loan. So an installment loan is a loan where you pay the same amount every month through the entire life of the loan. It makes budget planning easier because now you know how much your payments could be each month. You have nice regular payments. Another name for this is an amortized loan. So if you hear installment loan or amortized loan, that's just a fancy name for a loan where you make a regular payment every month until the loan is paid off. Now, it's kind of difficult to calculate this payment. We can't just take a percentage of the principal and figure out like what we're going to do, because remember, we have to kind of average out all these different payments and get one payment. So this is our formula. This is the formula that's on your formula sheet. This is what we're going to use to find the monthly loan payment. So this is the loan payment formula. You have to know your principal. You have to know how much you're starting with. You have to know your APR. The different interest rates can affect how much you pay. A higher interest rate, we're going to have to make bigger payments on that monthly basis. And it's going to be your number of compounding. This will almost always be monthly because most people pay off loans at a monthly rate, and that's what this N is. It's how frequently you're paying it off. It also has to do with the compounding. So these we're going to have monthly compounding. In real life, they're more continuous, so this is maybe not the most real-life practical type of formula, but it's going to be a little simpler than maybe the continuous compounding with monthly payments formula that we might need in real life. In real life, most of the time, we'd probably use a computer program, a calculator, to figure out these payments because the calculations get a little complex. So we're going to use a simpler formula, make things a little bit simpler for our class, but get to the same idea. Now you can kind of get an idea. And you could use this to get at least a reasonable guess about what your payment would be, even if you had a continuous compound. It wouldn't be that different, just be a little bit different. Okay, on the bottom we do have a couple set of parentheses here because we have to do 1 minus, we have to put in parentheses 1 plus the APR over n to a power, and this power, notice this has a negative n in it. One of the common mistakes I get in this class and people using this formula is they go to do this n and they do put a minus and not a negative because the calculator is picky. When you use this calculator, it has a minus button and a negative button. You have to be careful when you're using which one. When I want to do this 1 minus, that 1 minus right there, I need to use the minus button. But if I want to do a negative n, to put a negative in front of my n, whatever it is, maybe it's 12 for monthly or something like that, put a negative in front of that, I have to use the negative button. If you put the minus button, the calculator's not going to know what you're doing. You're going to get an error message. It won't calculate it. So you put a negative n times the time frame, so the time, how many years you have to pay off the loan, that'll be in there. And this formula will tell us what our monthly payment will be. And it's really handy. If I want to go borrow for a house or a car or something like that, this will at least give you a rough estimate of what it is. So it's something you could use in real life for sure. Just remember that it's going to be a little different because this is for like compounded monthly. So consider a student loan of $23,000. So someone borrowed $23,000 for school. APR is 6.8%. That's pretty typical for college loans. They vary a little bit depending on if you get them in undergrad and graduate and all that kind of stuff. 10 years would be your time frame, and we want a monthly payment. So n is this monthly payment is 12. So n is 12. 10 years is our time frame. 0.068 is our interest rate. Again, really don't forget to move that decimal 2 spots. People do that all the time. You really want to make sure you remember to move that decimal 2 spots to get that 0.068 for your percent. And our principal is $22,000. So we're going to find the payment. We're going to figure out how much we're going to pay, what our payment is, using those values. So we have 23,000 on the top, 23,000 times parentheses APR, so 0.068 over 12, because that's n, divided by, we're going to start our parentheses, do 1 minus, start another parentheses, do 1 plus APR, which is 0.068 again, over n, which again is 12. Close that parentheses, do a power, and do a negative 12 times time, which in this case is 10 years. Close that parentheses, and then you also need to close this parentheses here. So you close this one, you close this one, all the parentheses are closed. That's what we're going to type in our calculator. This one, I think some of the hardest part of this one is just typing in the calculator correctly and getting the right value, because sometimes it's really easy just to mistype this a little bit. So let's see if we can get this typed up so you can see. So 23,000 times, and it's lucky you actually can just type this top without any extra parentheses because the multiplication will happen before the division just because of how the calculator does order of operations. So I'm fine typing like this. I don't need any extra parentheses around the top. I just do 22,000 times 0.068 divided by 12. So now that's the top of it. And then divide and do my new parentheses. Do 1 minus parentheses because we're starting new parentheses. 1 plus 0.068 divided by 12. close that parentheses. Now I need to do my power, so I'm going to do my power button. A little up arrow, remember that's the power button. Down here it's under the pi. Up arrow, that's the power button. I call it the caret key sometimes. Parentheses, I'm going to do my negative 12. Make sure you're not doing a minus, so you have to do a negative 12. So you're not subtracting, you're just doing a negative 12 times 10, which you could have done that multiplication in your head, just put negative 120, and that'd be fine too. But I'm just going to type it as is. There's a lot of times when maybe the multiplication is not easy to do, so you would definitely want to type it out. Once I get that all out, I need to make sure I get out of the power before I hit the last parentheses. That way there's a parentheses on the bottom. Some calculators won't do it right if you don't have that last parentheses, and you don't want it to be in the power. Like if you have mine where the powers are up high like that, you definitely want the last parentheses not to be in the power. And then we finish off, get our answer. So this is our monthly payment. This is what we're expecting to pay every month for the whole 10 years to pay off this loan. So $264.68. So monthly payment, this is how much we're paying. This doesn't just pay off the principal of $23,000. Because if you paid this every month for 10 years, this would pay way more than $23,000. It also pays off all the interest that accrues the whole time. All the interest that occurs is also paid off, as well as the original principal. That's what this pays off. It pays off both. So now there's actually more to this problem. We found the payment. We figured out the payment, but the next thing it says, determine the total amount paid over the life of the loan. So to get the total amount paid, to find the total, we're going to take that monthly payment, that $264.68, and we're going to say we're going to pay that 12 times a year. 12 months per year. And in this situation, our time frame is 10 years. This is a 10-year loan. That's the term. We're going to multiply that by 10 for 10 years. And this is the monthly payment. And this is pretty typical. You'll see this anytime we find the loan payment, we figure out how much we're paying each month. The common thing to do with that is to figure out, okay, now how much are you going to pay? Well, you got to take that monthly payment times 12 months in a year, times the number of years, and get the total paid. So we can do this for houses, we can do this for school, we can do this for any situation where you know your monthly payment, you don't know how much you're going to pay. You just multiply the monthly payment times 12 months in a year times the number of years. And so in the end, I'm going to end up paying for this $31,761.60. And this is nice to know. If you go borrow money for school and you say, oh, I'm going to borrow this much, it's good to figure out, how much you actually end up paying. Well, if you borrow $23,000 at that 6 or 8%, you're actually going to end up paying $31,000, almost $32,000 by the end of the 10 years. And that's why banks like to give out loans, right? They know that if they give out this loan for $23,000, in the next 10 years, they'll end up with, closer to $32,000. So they're going to make some nice money. That's almost $9,000. So it's a pretty decent amount of money. And they just had to let you use their money for a while, and you still end up having to pay them back. Some of their money they got back right away. In 10 years, they got all that money back eventually. Okay, now that we know how much is total paid, this is the total for the whole line. The last part, they want to know what percentage is paid towards principal and what percentage is paid towards interest. So let's find the percentages. I'm going to use a different color so we can see. This is a different color. Let's do black, I guess. So let's do the percents. Now to find percents, remember you always take part divided by whole. And in this case, this total would be the whole. That's the total amount we pay. So to find the percent, let's first do the principal. That one's the easier one because we already know what the principal is. We know what the principal is $23,000. That's our principal. So if we take the principal, which is part of this total payment, and we divide it by the whole amount we paid, that $31,761.60, that'll tell us what percent is principal. So what percent of this payment was principal? So we'll go over here, we'll type in, we'll do 23,000 divided by 31,761.60, and that will give us the percent. It's in decimal form, so this is in decimal, so we end up with 0.7241, but that it becomes about 72.4%, right? If I move that decimal 2 spots to make a percent, and I'm going to round that off because the 1 will leave the 4 up. My math app will tell you how much to round, nearest 1 decimal or nearest 10th, probably be pretty common. So 72% of this is principal. So from this, we know 72.4% is principal. From interest, so you could just find the interest by taking 100 minus 72.4. So you do 100 minus 72.4. And we could say that 27.6% is interest. So that's one way to figure out. So principal is kind of easy to figure out, and then you can just subtract from 100 and get interest. That works great. The other way to do it would be to actually find what amount you paid in interest first, and then just divide the interest by principal. To find the interest, we would subtract the original principal from the total. So we're subtracting principal to get the interest. So if I subtract this, I end up with $8,761.60. If I subtract 31,761 minus this 23,000, and that's the number. So to find the percent interest, I would take that $8,761.60 and divide that by the 23,000. Oh, sorry, not 23,000. That's the principal. I want to divide by the total, $31,761.60. That'll give us the percent that is interest. So we're going to divide to find percent. That's pretty typical. Divide to find percent. So you take the part, divide by the whole. The part that we paid the interest, so the 8761.60, which is interest, divide that by the total we paid, 31,761.60, and that'll give us our percent that was interest. And you see that it's actually 0.2758, which again would become 27.6%. So that's what we said, right? We were right. That works fine. So you can see how there's either way works. If you want to find the interest and then divide to get the percent, that works. Or if you just find the principal percent and then subtract from 100, you got the interest percent. Because those two should always add up to 100. The interest percentage and the principal percentage, those should always add up to 100%, because that should be your whole loan. And it might be off by just like 0.1 because we did round a little bit on these two, but usually it should be pretty close to the exact number. Okay, so what you see here is that 3/4 of what they pay, almost 3/4 of what they pay, it goes to principal, but about 1/4 of what they're paying is actually going to interest. And that's because this is only a 10-year loan. The longer your loan is and the higher your interest rate, the more of this will actually go to interest. So that's why like 30-year home loans, you end up paying a lot more in interest. Maybe not double, twice as much as what you paid for principal, but a good chunk of it will go to interest. It's almost 50-50, I think, for a 30-year loan. It depends on your interest rate as well. Let's try the next one. So choices of rate and term. Often you will have multiple choices of interest rate. You have different options for interest rate and loan term when you seek a loan. The rule of thumb is that shorter term loans will come with lower interest rates. So why is that? Why is a shorter term loan have a lower interest rate? Well, the bank looks at it and says, if I give you the money for 15 years and interest rates just climb over the next 15 years, the whole time you have that loan, I'm not being able to take advantage of those high loan interest rates, the higher interest rates, but because you have to pay me back in 15 years, I'll be able to take my money and go reinvest it for the next 15 years at that new higher rate that's happened. Versus a longer loan, like a 30-year loan, that person is stuck in at that rate for 30 years. So their money, they gave it to you, they have to wait 30 years to get it back. The whole time, yes, you're going to be paying them with interest. They're going to be making interest, and that helps. But they might have been able to make more interest if after 15 years they've been taking that loan money that you paid them back and give it to someone else for a higher interest rate. So the rule of thumb is that a shorter term loan has a lower interest rate because the bank can afford to give you a little bit better interest rate, a little lower interest rate. They're not giving quite as much money because they know they're going to be able to reinvest that money within 15 years. Versus if you get a 30-year loan, they have to wait so long that they're not going to be able to reinvest it as quickly. And so then they're going to charge you a little higher interest rate to start with so that they're not losing as much money if interest rates change in the long run, kind of thing. So shorter term, lower interest rate. However, because you're paying it off faster, they typically have a higher monthly payment. It takes more money to pay off a loan in 15 years than it does in 30 years because you have to pay it twice as much each month, twice as much principal. Maybe less interest, but the principal's bigger. So in the long run, though, the shorter term loan with the higher payment will actually lead to a smaller total over the life of the loan because you really pay less interest. You have a lower interest rate and you have less time for that interest rate to compound. So in the long run, when you finish paying off your house, you will pay less money if you get a 15-year loan versus a 30-year loan typically because the interest rate is lower and you're not paying as many years worth of interest. That's why the people that can try and take a shorter term loan. The hard part is you have to be able to afford that bigger monthly payment. And that's the cutoff. A lot of people look at, I can't do that. I can't pay a bigger monthly payment. I could pay, less, but I can't pay that bigger one, the higher one. That's just too much. So let's look at this for a situation. For example, you need to purchase a building to expand your business. You can either obtain a 15-year loan, so we're looking at a 15-year loan with a 4% APR, or a 30-year loan with a 6.5% APR. So like I said, what you see is that the shorter term is going to have a lower interest rate because they know they're getting their money back faster, versus the longer term is going to have a higher interest rate because they know they have to wait longer to get their money back. We're going to borrow $240,000 for this house either way. So this building, it's going to cost us $240,000 either way. The term and the interest rate change, but the amount for the building is the same, and it's going to be monthly payments either way. Like I said, this is almost always 12 for these. There's not very many where the payment won't be monthly because when you pay off houses and buildings and stuff like that, you typically pay monthly. Okay. Find the monthly payment for each and the total paid over the life of the loan. Which loan is the better option? So first off, we want to find the monthly payment. So let's look at that 15-year loan. Using that formula that we had on the previous page, we're going to go back and we're going to still use this formula, payment, principal, all that kind of stuff. We have the principal, which is the $240,000. The payment, the plan is monthly, so it's 12. In this case, our term would be 15 years, and our APR is 4%. So using that formula, we would write down, we would have the payment, the monthly payment, is going to be equal to that $240,000. And typically we'd expect the building to actually cost more than $240,000. This is just how much we're borrowing. So it might be like a $300,000 building, but they are putting $60,000 down. Don't forget those down payments always typically happen. In this case, though, we're kind of past the down payment. We're saying, okay, now we know how much we're going to borrow. We're going to borrow $240,000. And we want to figure out how much we have to pay on payments on that. So we might have already made a big down payment. We just are skipping that part for this question. APR for this situation is 0.04 because it's getting that shorter term, you get that better rate. And it is N is 12 because it's monthly. On the bottom, we have that 1 minus, parentheses 1 plus, APR, which again is 0.04, N is still 12. And the power is negative 12, because it's negative N, times the time. In this case, the time frame is 15 years, because it's a 15-year loan. Don't forget to close that bottom parentheses. So again, that's just using this formula, plug in the principal, the APR, the N, and the T in this formula. That's what we did. So that will give us his monthly payment for this loan. So let's see if we can figure that out on our calculator. Again, that's going to be some of the hard parts of this section, is just typing all these things in the calculator correctly. So first off, I'm going to do 240,000 times parentheses 0.04 times 12, close that parentheses, divided by parentheses 1 minus parentheses 1 plus 0.04 divided by 12. Close that parentheses, do my power, and then do parentheses, and remember the negative button, not the minus button. Negative 12 times 15. Close that parentheses, use the right arrow to get out of the parentheses, out of the power, and do the parentheses there. Now it's all closed off, we should get our monthly payment. Oop, that's when you know you didn't do it right, when the payment is bigger than the the whole price of the house. So that means I've typed something wrong. That's where I highlight it. I went up twice and highlight it and hit enter. And now I can go review and say, what did I mess up? I messed that, type something. Negative 12, 15 years, 12.04 divided by 12. There's 1 plus, 1 minus. Is on the top part, 0.04 divided by 12. Uh-oh, this tells me I did something wrong, but I missed where I made the mistake. So we have 240,000, 0.04. 12, 1 minus 1 plus 0.04 for 12. Let's double check. Okay, times 12, divided by parentheses, 1 minus parentheses, 1 plus 0.04 divided by 12. Close parentheses, do the power, negative 12 times 15 There's no way the payment could be 255,000. I can't find my mistake, and it still gives me the wrong answer. 240,000. Oh, there it is, right there, staring me in the face. I have times 12, and it's supposed to be divided by 12. Yep. This is a calculator. It's really important to make sure you double check your values when you're typing stuff in. Make sure you're not just assuming that you got things typed in correctly. Because even a teacher, like me, who's been doing this for years, I hit the wrong button every once in a while, and I get the wrong answer. So you got to make sure that as you're typing these, always double checking your answers, make sure they make sense. And this one was pretty obvious. We knew it made sense as soon as we found out that it was going to take us $255,000 a month to pay off this loan. That's way too much because this is a $240,000 loan. We should only be paying a small portion of that each month. Okay, so now we get a little bit better answer. It's still a pretty big number, but it's definitely nowhere near hundreds of thousands. So this is a much better answer. So $1,775.25. And yes, this is more than what it would take to pay off just $240,000 in like 15 years. But remember, this is also paying 50 years worth of interest as well. So that's why it's still a big number. We have that 15 years worth of interest as well. Now let's try it with a 30-year loan. So the 30-year loan is going to be very similar. The only difference is going to be the time frame and the interest rate. Otherwise, it's going to be the same value. So the $240,000, that's the same. It's the same amount of money we need to borrow. The interest rate changes, so that becomes 0.065, but it's still a monthly loan, so that's still 12. On the bottom, we still have that 1 minus, parentheses 1 plus. Now it's 0.065 over 12 again, and the power is negative 12, but this time times 30 for that. Oh, don't forget that parentheses there. And I forgot my big division bar. Now, the nice thing about this is you don't have to retype this whole thing in the calculator. You can kind of cheat a little bit by just taking your calculator. That's not really cheating, it's just faster. Go up arrow twice, hit enter on that. Yeah, it's a little wrong because it has the wrong dates, but we can go back and fix that. So we can go over to where it says 15 and just type 30, and I'll type right over top of that 15. Now the 0.04 is a little bit harder to fix because we need to turn that to a 0.065. If I type the 6, that's over the 4, but if I type the 5, it would mess up my division. So I'm going to hit second and insert, and that'll let me type the 5 there. So we have 0.065. That's a little bit easier way than having to sit there and retype everything. Because I can just change the one thing that changed, or two things that changed, the term and the interest rate. I'm going to change this 4 here. I'm going to change that to a 6, and do second insert. So I can make that a 5, and now it should be correct. And again, it's a smaller payment. That looks so much better because we're like, oh man, now I only have to pay $1,500 each month instead of $1,700. But what's really happening is now it's taking you twice as long to pay this off. So you think about this payment is only happening 12 times a year for 15 years. This payment's happening 12 times a year for 30 years. So we're paying a significant amount more. And this is where people get caught in the, things like compound interest and paying loans and stuff. They look at these two and they go, well, why would I pay the $1,700? I could pay the $1,500. If they don't understand the math, the fact that, well, the reason the $1,500 is so cheap is because in the long term, you're paying a lot more because you have so many more months, so many more years of paying it off. You actually save a lot of money by doing that 15-year payment. It's just you have to be able to afford the 15-year payment. It takes a little bit more money to pay that off. So let's look at our difference in the totals. So first off, the total for the 15-year, well, to find the total for that one, we're going to take that payment, that $1,775.25. We're going to multiply it by 12 months in a year, right? Because we're paying us every single month. And this time we're going to multiply it times 15 because this is a 15-year loan, right? So it happens for 15 years. That's what we're going to multiply. So I'm going to do this 1775.25 times 12 times a year times 15 years. And I end up with $319,545. It actually comes out to a nice round number, which is kind of funny, but that works. So $319,545, no cents. That's how much we end up paying. So over the life of this loan, even though it was only $240,000 borrowed, we're going to pay almost $320,000. So that means we're actually paying like an extra $80,000. That's why banks like these big house loans and stuff like that. Because yes, they had to give you $240,000 now, but they expect you to pay them back an extra $80,000 in the next 15 years. They're making some nice money. Now for the 30 year, they're going to make even better money because now they're taking this $1,516.96 payment times 12 times a year, because it's still monthly, but it's for 30 years. That's twice as many years, right? This payment is going to happen twice as many times. It's going to be a lot bigger in the long run. So 1516.96 times 12 times 30, and that gives us $546,105.60. You can see that's a way bigger number. That's a lot more. It's not quite double the other payment, versus like the 15-year, but they're making so much more money. This is such a huge difference for them. So if you're the banker, you say, well, yeah, I'd love you to take the 30-year loan. Yeah, I have to wait 30 years for my money, but by the time you're done paying, I've almost made, for versus 240, I've actually more than doubled that. So they've actually got a whole other house in those 30 years. They could go buy two houses for the amount of money that you borrowed from them. So they made a lot of money off this. This is how lenders make their money. They charge you the interest. It compounds, year after year after year. Each payment doesn't look that bad compared to, like that payment. It's a little bit nicer. But over years and years of doing this, it adds up to a lot of money. The interest rate has a big impact on this, and then also the number of years. So remember, again, this one was charging a higher interest rate. That's part of why this went up. This total went up. And then I was doing it for 30 years. And those two numbers are what drove this price so much higher, where we charge you so much more interest. So which one's the better option? Well, at the end of the day, even though we kind of know the 15-year is going to save you a ton in interest charges over the 15 to 30 years, some people are going to still pick the 30. I have a 30-year loan on my house. I wish I could be on a 15-year loan, but I didn't feel like I had enough money that I could make the higher payments I would have to make. I thought in my situation I was better off just taking the 30-year loan. Yes, it'll take me longer to pay it off, but I knew I could make those payments, and so I wouldn't have to worry about losing my house because I didn't make my payment. That's something people have to worry about. If you lose your building if you don't make your payments. So in this case, there's not one right answer. Like, yes, 15 years is cheaper on the total, but that 30-year loan is cheaper in the individual payments. Now this one is fairly close. You can see it's only actually $260 difference. So they might really push themselves to try and make up that $260 difference and do that higher payment each month, because again, that's really going to save them a ton in interest payments in the long run. So we'll say 15-year is cheaper total, but has higher monthly payments. And that's pretty typical. That's kind of what we expect to see. We expect to see a cheaper total. We're paying less in interest over the whole life of the loan, but we expect to pay a higher monthly payment. And so if you can make that higher monthly payment, you can really save a lot of money. That's one thing people try and do. Okay. Mortgages. One of the most common installment loans is the home mortgage. Most people that deal with an amortized or installment loan in their lifetime, it's because it's their home mortgage. They bought a house and they have to pay back the whoever they borrowed the money from. It's designed specifically to help you buy a home. Mortgage rates are generally lower versus other types of loans because the home is the collateral or the guarantee that you'll pay the loan. The idea is that if you don't pay your loan back, if you don't pay the bank back, they call it repossessing the home. They take ownership of the home. They might have police come and evict you if you're not making your payment. They kick you out, and then they go and they sell that home. And because it's a home, it usually retains most of its value, even if you have to kick someone out. Even if that person does stuff like strip out the appliances and stuff, the building, the land usually has enough value that they can get most of their money back out of it. They don't usually get all their money back out of it, so most banks will actually work with you to avoid repossession because they don't really want to repossess your house. They really just want you to make your payments. But in a situation where someone's not making their payments, where the person has decided, I just can't make my payments, or I don't want to, then that's what the bank does. They take the home back and then they sell it as quickly as they can because they don't want to hold on to it usually very long. They just want their money back out of it, and then they can go try and make more money loaning to someone else. So that's the collateral. Your house is the collateral. That's what the bank takes if you don't pay. Most lenders do require the borrower to pay a portion of the home cost called the down payment. Right? We've talked about this before. Before they'll give you a loan, they want the down payment. And the reason is that if you go to borrow for that, buy that house, and you borrow $300,000 from the bank, but you don't put any money into it yourself, you could live there for 5 years, pay monthly payments on it for 5 years, which are probably actually cheaper than rent because you're not having to pay a landlord, you're just paying for the house itself. You could walk away after 5 years and say, well, all I have is those 5 years of payments. I would have paid them out, same amount for rent at a apartment building, and so now I can walk away, and the bank they can just repossess the house and try and get the rest of the money out of it. And that's what people do sometimes is they decide, well, I just don't want to keep paying on this loan. I don't, maybe the house, I don't think it's worth what it was before. I need to move somewhere else, whatever. They have a reason. They stop paying, and the bank has to repossess. Well, when you do a down payment, what happens is you put some money in right at the beginning. So then you've made, put in 10, 50, however much money, 10,000, 50,000, 100,000. And now, if you walk away from that house and let the bank repossess it, you're out all that money. As soon as someone puts $50,000 into a house, they have a lot more investment in keeping that house. They can still decide to sell it later in the future. They could just sell it and get the money back and pay off their loan, and then whatever left, they would get back towards their $50,000. If they sell it for more, they can actually make a profit. That can happen. But if you're not taking care of your house, or if your house's value drops because of circumstances, I think of locally, we had a situation where there was a sinkhole. A lot of houses just plummeted in value right away. I'm sure most of those people, if they had houses, just walked away from them because they couldn't live in those houses. They weren't safe, and they had to decide, well, do I keep paying on the loan for this house that I can't live in, or do I just let the bank repossess it? And the bank ends up repossessing it because it's just not worth anything. Well, the bank can't sell it either, so it's not great. That's kind of a terrible situation for everybody involved, but that's the kind of thing where someone might just decide, I'm not going to keep paying on the house. Even if you have maybe a down payment, they might have walked away from that rather than try to sit there and pay on a mortgage on a house that's not worth anything. So down payments are important. It's kind of the way for the lender to get the person borrowing the money to get a little bit of their own skin in the game, a little bit more investment in the situation versus someone that just walks in and borrows all the money for the house. After the down payment, there's also the loan. When you get the loan, there's actually a lot of fees associated with obtaining the loan, the mortgage. So there's a lot of direct fees charged by the lender and the title company. So banks say, well, we have effort and work we have to put in here. If we don't have our own money that we can lend you, we actually have to find underwriters. So these are people with a lot of money that are looking for good investments. The bank goes and says, hey, this person needs a house. They want to borrow money. We think they'll pay us back. Here's their credentials. They usually get your financial statements and roof income, stuff like that. And they say, this person's a good investment. You should borrow loan money. We'll take that money, give it to them, and then you get paid back. Well, that takes time and money to find that out. And they have to usually have an appraiser come out and look at the house and make sure it's worth what they say it's worth, all kinds of stuff. So the bank usually charges fees to pay for all that kind of stuff, pay for the employee, does that work. And then there's also fees for the title company. The title company typically looks at a house and makes sure that the person selling it actually owns it, that the lot's described correctly, all that kind of stuff. They look for a chain of ownership, look for the different deals of sale. Because it actually has happened in the past where someone sold a house and someone bought it, and then they found out that that person didn't even own the house. And so then they didn't own it because they had bought it from someone that didn't own it. And then they end up finding out that the money that they put into this house is gone because they didn't actually buy the house. Unless they could track that person down and get the money back from them, they could just be out the money. And so the title company kind of keeps that from happening. They track down who's the rightful owner, make sure that the land's described properly, that kind of stuff. So there's a lot of time and money that goes into that. So those are fees. So when you get a mortgage, there are fees. On top of the price of the house, these fees happen as well. Now on top of those, there's also fees that can be charged as points, which are a percentage of the loan amount. Points we mentioned earlier, points are important. Points let you decrease the interest rate on the house. When you pay points, you get a lower interest rate. So that's what points do. And not every loan will have points. Some people will just get their mortgage straight. They won't have any points. I didn't buy points for my mortgage, so I just got the interest rate the bank offered me. But sometimes people will pay for some points to get their interest rate down, and that will help them pay for this house because in the long run, they'll save a lot of money on this interest. So let's look at an example and kind of see how this works. Oh, I guess I really should mention points are not charged on the house's price, but they're charged on the principal or the amount you borrow. So if you go buy a $500,000 house and you pay $50,000 down, so you're only borrowing like $450,000, then the points would be a percentage of that $450,000. That's what you usually end up paying for those points. So points are important, down payments are important. You really want to make sure you understand what points and down payments are. They'll show up in the project, show up in the test. So say you want to purchase a home for $430,000. You are required to make a 10% down payment. So this is the cost. It's not how much you're borrowing, it's the cost of the house, and you need to make a down payment. So you want to find out what your down payment should be. Typically, down payments are a percentage of the house. You could decide to pay a certain amount, even if it's not a specific percentage that you're looking for. Like someone might just say, "Hey, $430,000 house, I'm going to pay you $50,000," and that would be a down payment. But a lot of times people look for a certain percentage target. There's actually benefits if you pay a high enough percentage down payment. You can avoid some extra fees and costs associated with buying a house. I think the cutoff is if you pay at least 20% down, you can avoid a lot of like fees and extra costs. So here you go. We have the cost of the house. We want the down payment. Well, the down payment is pretty easy to find because the down payment is just the house cost times the percentage you want to pay. So just multiply it times 10% or 0.10, and that'll tell me how much I need to pay for down payment. So when you're doing down payment as a percentage like this, just take that percentage of the amount, so multiply it, and that'll tell you what it is. In this case, it just ends up being $43,000 because 10% is always the number with one less zero. That's kind of a trick for doing 10% of something. So $43,000 is your down payment. That tells us that even though the house costs $430,000, right now you're only going to pay $43,000, and then you're going to borrow the rest. You're going to only borrow what's left over after you pay this down payment. So the principal, how much you're actually going to borrow, is actually going to be that $430,000 minus. I got an extra zero there. $430,000 minus this $43,000 down payment. That's how we find the principal. How much you're going to borrow? You take the whole house, subtract the principal. I'll probably do this in my head, but I don't feel like it, so I'm going to do $430,000 minus $43,000. And say that it's going to be $387,000. So we're actually going to borrow $387,000, not the whole $430,000. That's pretty typical with mortgages. There are some exceptions. There are actually situations where you might not have to make a down payment. They have that for like veterans loans and stuff, just to have a special perk to help out our veterans, which makes sense. So there are type of loans like that. But this is typical. Most people, if you buy a house, you have to put some amount of money down and then borrow for the rest. Okay, now after we did this, we want to look at the points, the fees. So closing costs include both those direct fees, the ones you just get charged because you got the loan, and the points. Together, those are closing costs. So closing costs are important because when you go to buy a house, a lot of people know about I got to pay for the house, but they don't realize you have to pay these closing costs as well. That's why you have to have some money saved up, for your down payments and for your closing costs. The closing costs, we're going to find these by finding the direct fees, the ones that just are, no matter what, you have to pay these. So that's going to be things like your $6,000, because that's just the bank saying, hey, if you want to get a loan for us, you have to pay $6,000 to us and the title company. You pay these fees, and it covers our costs. Plus, you decide you want to pay 3 points to get a better interest rate. Well, the 3 points are going to be a percentage of the principal. So we're actually going to take this principal, $387,000, and we're going to multiply it times the 0.03. So the 3 points is 0.03, or 3% of the principal. This is one of the common mistakes on the project I've seen in the past and stuff on the test, is people trying to do points, and they're taking points of like the $430,000, but you didn't borrow $430,000, you only borrowed $387,000 because you paid a down payment. So points you always calculate on the principal, not the house cost, because usually you don't borrow the full house cost. That can happen, but it's very rare. It's a lot less common. So to find this, I'm going to go ahead and just do the $387,000 times that 0.03. And that told me right off the bat, my points are actually charging me 11,600. So this is actually the bigger part of the closing cost right here is the points, because trying to lower that interest rate, yeah, it costs me 11,000 right now, but in the long run of this house, it could save me a ton of money. So it's worth it to put in that $11,000, because in the long run, it might bring down my total cost. Adding the 6,000 direct costs, flat fee costs, I end up with $17,610, and that is the closing costs. So after you've already paid the down payment, you still have to pay this. So if you're going to do this, you have to have enough money saved up to pay that down payment, $43,000, plus pay these closing costs. You end up in this situation, you have to have like $60,000 just to get the loan. And in real life, not everybody has that. That's why some people don't buy these points, because they can't afford them. Sometimes people will. In my situation, I got my seller to pay the closing costs, the direct fees. So I didn't pay those. That was kind of a bargaining. So I paid a little bit more for the house, but they paid the closing costs. I could have, maybe got them to bring the house price down instead, but it worked out good for me because then I didn't have to put that upfront money. I ended up paying more in the interest in the long run, probably. But again, that was my situation. Every situation is a little different. There's not one rule where everything's always the best. You can't always get the best option. Okay, a couple interesting things about mortgages, or a couple types of mortgages. They really come in two flavors, if you will. The first one is the most common. It's called a firm or a fixed rate mortgage. These are fairly simple and safe. These are the traditional, you get your interest rate and it stays the same for the entire life of your loan. So like my interest rate is the same as it was when I got my house. Actually, 10 years ago now, I bought the house. It's been the same amount, the whole time. The interest rate never changes. So this is the simplest type of home loan. They guarantee their interest rate will never change for the life of the loan, which means your payment won't vary. It might vary a little bit because of taxes and that kind of stuff, but the interest payments won't vary. Typically when you pay for a house, you pay for the taxes, insurance, that kind of stuff. But the mortgage payment, if you have a nice fixed rate mortgage, the mortgage payment itself is the same every month throughout the whole life of the loan. You're paying that same amount for the mortgage rate. It's just the insurance and taxes that might vary a little bit. These usually have 15 to 30-year terms. Sometimes you get like a weird 20-year, that can happen. But that's pretty typical. Because these are so fixed and safe, they usually actually have a little bit higher interest rates versus the other option, which is adjustable rate mortgages, or ARMs. So here talking business people talk about an ARM. An ARM is adjustable rate mortgage. These are a little more complex and they are a little risky, because these loans start with lower interest rates. They actually are a little bit cheaper to start with, a little lower interest rates than the firms. But after 6 months to a year, sometimes even 5 years, it depends on the loan. After that, the interest rate changes based on market trends. So they wait the required period of time it's given out in the loan, whether it's 6 months, a year, 5 years, whatever. They wait after that period's done, and then they look at whatever index. There's indexes you can look at that kind of track like mortgage rates for the country. They look at the one they decided for the loan, and they say, are the interest rates up or down? What's happened? And then your interest rate changes accordingly. Now, a lot of times interest rates do raise, so it's very likely that after that period of time, your interest rate on your loan will go up. They usually set limits, so it can only go up so much per year and only so much total over the whole life. So you can't hit beyond a certain cap. So you'll kind of know what your maximum payment will be if that you get to that point. So you know what you can't get above. But it's risky because you might start off with a decent payment, and then in the long run you might end up with a lot higher payments throughout the rest of the life of the loan. That's why these are risky. And they're a little more complex because your interest rate changes all the time. Your payments can change. So you have to really watch that. So these do work for some people, though. These are actually really good for homeowners that are going to spend less time at the home they're purchasing, because the first few years you get really good interest rates because they haven't had time to go up very much. You start with a low rate, and then it only changes a little bit each year. And adjusts so much they can't adjust too much. So if I teach close to a military base where a lot of students are from the military, they really work great the ARMs work great for them, because they know, I'm only going to be on this base for a couple of years and then I have to move to the next base, and I'll just sell my house when that happens. So they buy a house with an ARM, adjustable rate mortgage, and they say, okay, well, in 2-3 years when the rates start going up, I'm going to be gone. I'm going to move on to the next house. So I'll just sell it. And so it won't be a big deal. I'm not worried because I'm not going to pay off all 15, 30 years. The bank doesn't know that when they give it to them, but most of these loans, they don't care. They let you pay them back and they just take the money and reinvest it with someone else. So a lot of these loans, like I said, though, do end up with higher payments and maybe more interest over the life of the loan because interest rates change. Like I got my house, interest rates were pretty low. If I went out and tried to get a new loan right now for my house, the interest rate would be a lot higher. If I was on an adjustable rate mortgage, my interest rate now would be much higher than it was when I started. And that's not true for everybody. Sometimes it does go down for people, but you have that risk. And that's why adjustable rate mortgages can be pretty tricky, pretty risky. So unless you're in a really specific situation, you might want to avoid those. On the mortgage project, I'm only going to let you do the firms because I think for most people, the firm is probably good. Unless you're in specific situations, you don't want the adjustable rate mortgage. Okay, last thing to talk about. So when you go to pay off these houses, these big payments, one thing you can do is you can actually pay a little bit early and save a ton of money in interest. So let's look at kind of the lifespan of a loan and see how this works. So during the early life of your mortgage, so the first few years you're paying on the mortgage, payments are almost all entirely interest. We saw it on the very first page. We saw how the first payment was like $700 and only $200 was principal because the rest was all interest. And that's pretty typical. When you have a big loan, at first the loan is huge, so you're paying a lot of interest. So this chart below here actually shows this for a loan where they have $100,000 they borrowed at 5% interest rate for 30 years. And you can see how the top half, that's actually their interest. So this lighter color, that's their interest. And the darker color on bottom is their principal. And so each month, if you look at like one part here, like month one, you can see that most of their payment went to interest and then just a little bit went to principal. And they do that over and over again for a few years. But as you go, because you've been paying a little bit of the principal each month, your total loan has actually gotten smaller and smaller. So over time, your interest amount is less. Well, if you pay the same amount, because these are amortized or installment loans, you're paying the same payment every month. This one ends up being like a $537 payment. Every month they're paying $537. Well, when the interest is big, most of that goes towards interest. But as you go, eventually you've paid off enough principal that now you're paying less and less and less and less interest. As you get to the very end, most of your payment goes towards principal. Not very much goes to interest anymore because the loan's pretty small at that point. So that's what happens over the life of a loan. Now what that means is, if you want to save some extra money, what you have to do is you have to pay a little bit extra principal early on in the loan. So here's the example. One way to save a lot of money on a loan is by paying extra. You can save a lot of money if you can reduce your interest payments. As long as there are no prepayment penalties. There actually are loans that have prepayment penalties where if you pay extra early, they charge you a fee for that. Those are much less common now than they used to be, and they have to disclose that. When I got my mortgage, I swear it said on every other page, no prepayment penalties, like they weren't going to charge me for paying early. And so they will have to disclose it if they're charging you fees for paying early. And, that's something you can definitely directly ask and say, are there prepayment penalties? And if there is, you probably want to walk away and go find a different loan, because it's not a great situation to be in as the borrower. You're stuck having to pay this off over the time frame they want, unless you want to pay extra. One way to do this is by paying extra towards the principal. That's one way to save money, especially early in the term. So here's a cool example. If you pay $100 in this loan, the first month, you save the compounded value over the next 30 years. Because if you hadn't paid that extra $100 now, that principal would have just sat there for until we got to it eventually. So we can save basically that compounded value for like 30 years. That equates to like $450 in 30 years. So each of these $100 payments you're making early on is saving you hundreds of dollars in interest. And also, if you keep repeatedly paying a little bit extra each month, you can actually save money not just save money, you can save time on your loan because you get to pay it off early. If I pay the $537 every month, well, I'd be done in 30 years. But if I pay $637 each year, I might be done in like 25 years. Depending on the interest rates and stuff, it might be earlier. It depends on what's going on. So a little bit each month, even if it's not $100, even if you only pay like $50 each month, you can actually save hundreds, if not thousands, in interest. And probably thousands, I should say. Probably thousands or tens of thousands of interest if you're paying it every month for years. And you'll be done paying your loan off, several years early. So in the long run, you won't have to pay as much. So that's one way people save a lot of money on a mortgage, is they pay just a little bit extra each month. Even if they can't afford a lot extra, even if you only do $20 extra, you could save a lot of money. And the more you pay extra, the more you'll save. Now, if you want to be even more extreme and want to like a way to save you more money, there's the half-term payment trick. This is what people do. So this strategy for paying the loans off early is to take the bigger time frame, the longer-term loan. It's going to probably have the higher interest rate, so you're paying higher interest, but they pay it off faster. They pay it off in like 15 years. So they calculate what the payment would be if they had a 15-year loan at 5%, and they make that payment instead. Now you might say, well, why don't they just take out a 15-year loan? Well, the nice trick for this one, the thing that's nice about this one is you can, make the 15-year loan payment as an option, but if you have a hard month, if something, medical bills come up all of a sudden and you need to drop back down to the lower 30-year payment, you could do that and then come back to 15 years when you're able to. So people in this situation have options. They can say, okay, if I keep making 15-year payments, my loan will be gone in 15 years. I'll save 15 years worth of interest. It'll be a lot cheaper than I paid it off over 30 years. But if I need to, I can go back and just keep paying my 30-year payments. And that's why people will take this one. It's a great option for someone that wants to have a kind of a hedge their bets, make sure that they're safe in a bad situation, but also wants to pay off their loan in a quick way. So for example, let's look at an example of this happening. So find the savings made using the second strategy in this situation. A home mortgage of $360,000 has an APR of 8% and a term of 20 years. You decide to pay it off in 10 years. So to figure this out, first off, we're going to think about, well, if you paid it off the typical 20 years, your 8%, $360,000, home mortgage, it's got to be monthly 12, because that's typical for these. We'll go back and use our mortgage formula we've been dealing with. So this loan payment formula. Then we would find our payment, I don't want to do an A, I want PMT. So we do principal, which would be $360,000. We're going to say that's the principal, that's how much they're borrowing, not how much the cost is because they already paid their down payment. APR is 0.08, over N is 12. Over this we get 1 minus 1 plus 0.08 over 12. Close that off. Power of negative 12 times 20. This is a 20-year loan. Not as common, but they happen sometimes. You can have a 20-year loan. This person wants to pay that, this off faster. But we're going to see first off how much they would pay if they paid it 20 years. We'll do 360,000 times that parentheses 0.08 divided by 12. Close that off. Divide by parentheses 1 minus parentheses 1 plus 0.08 divided by 12. Close that off. Power, parentheses, negative 12 times 20. Close that. And then don't forget to get out of the power and close the big parentheses. And in this case, their payment, their monthly payment, would be $30.1118. Now, if they wanted to pay this off faster, they'd have the same payment. The only difference is their 10-year time frame. Sorry, I shouldn't say payment. Same principal. 0.08. They have the same interest rate, where they don't get a lower interest rate because we didn't take a lower interest loan. We didn't take a shorter term loan. We're doing a 20-year loan. We're just trying to figure out, okay, what if we paid it off in just 10 years? So in this case, the interest doesn't change. The only thing that's going to change is the time frame. So they're going to think, okay, what would I get to pay if I paid it off faster? So in this case, negative 12 is times 10 instead of 20. That's the only thing that's going to change, but it's going to change my payment. So I'm going to use my trick, go up here, hit enter. That's all retyped. So all I have to do is change this 20 to 10 years. So I'm paying it off in half the time frame. You'll notice the payment's going to be quite a bit bigger because now I didn't have a savings and interest. Because before, when we did this kind of trick with 15 and 30, we did a little bit before, we actually had different interest rates. Well, this one you'll have a different interest rate, so you're actually almost just doubling your payment. You're really just adding principal, but that's what's happening. So they have to pay an extra $1,300, and that's a lot more extra. That's a lot different than just paying $100 extra. $1,300 extra is a lot harder to do. However, in the long run, this person, if they do this way, they're doing 30, 11, 80. 18, times 12 months a year times 20 years. And this one is that 43, 67, 79. But this is 12 months a year for 10 years. So we're going to see a significant difference in the total payments, because one is twice as many payments as the other. That makes a big difference. So we get 3011.18 times 12 times 20. So in the long run, on this one, they would be paying 722,683.20. And the other one, so 4367.78 times 12 times 10. This one, they would pay 524,133.60. So in the first option, they end up paying 720,000. Second option, it's only 520,000. They're going to save $200,000. That's most of what they had, price of this house. That's like almost more than half the price of this house in savings by paying it off in 10 years versus 20 years. It takes a much bigger payment, so you have to be able to make that bigger payment. You can see why it's nice to have a fallback, because if there's a month where you can't make $4,300 for your payment, you need to be able to step back and do the $3,000. That's necessary, but they can save quite a bit. So I guess to find the savings, we'd subtract them. So we'd take the 722,683.20 and subtract the 524,133.6, and that would give us their savings. So they actually save exactly $198,549. So the savings would be $198,549.60. And you can see why someone might want to save $200,000. I don't know about you, but that's a lot of money for to me to think about. Like, I could save that just by paying this off faster. All right, that's it for this section. So it's all about these loan payments. You really need to be able to use this loan payoff calculator. Again, this formula. It's for when you want to find your payment for a loan. So when you're going to the test, or going to the quiz and stuff like that, trying to figure out which formula to use. If you're trying to figure out what your monthly payment's going to be on a loan, that's when you use this loan payment formula. Done for this section. Next time I'll see you, we get to do taxes. Everybody's favorite section for this unit. Maybe not, but hopefully we can make them seem a little more understandable and we can have a good time with them. I'll see you then.